Okay, so we've got the communication matrix below shows the direct paths which messages can be sent between two people in a group of 6 people, U to Z. So what they've just shown us there is what we call our plain C. This is communication 1 step. So just so you know, that's 1 step. And then it says, and it will tell you the ruling behind it, which we've already explained to you, but it'll say that. So if there's a 1 in the matrix, it means that person can directly talk to the other person. Okay, so, and then they'll give an example. So for row 4, column 2, that shows X can send a direct message to B. So all of that blurb there, don't worry, that's just the normal ruling, yeah? We've already know that, but they have to write it out. Okay. It's in the question, it says, in how many ways can Y get a message to W by sending it directly to one other person? So they're going to send it to a person and one person first, and then it'll go to W. So that is actually 2-step communications. So it's saying, in how many ways can Y... So it's the 2-step communication between Y and W. So what I've done in here, this is I've typed out on my calculator, we've typed out, this is C, okay? And then to get this 2-step communication, I've taken C and I've raised it to power of 2, and here is, so this is C squared. So this is 2-step communication. So we're looking for between Y and W, and you can see it's got a 0. So there is actually 0 2-step communications. So we just pick the answer 0 there. Okay, so the main computer system in Elena's office has broken down. 5 staff members, A, B, C, and D, and E are having problems sending information to each other. The matrix below shows the communication links between the staff. So when they've given, this is when they just say communication, that's a plain 1 step, yeah? So we've got 1 step being given to us. And once again, they're just explaining what 1 step means. Like, you know, a 1 means they can communicate with each other, 0 means they can't. So it says which 2 staff members can send information directly to each other. So what you're wanting to see is that if you have a 1 between 2 letters, you want a 1 in both combinations. So someone just shouted out, what did you think? B and D? Yeah, so if we look between B and D, here we can see a 1, and then down at D, D can also go to B. So because there's a 1 in both combinations, all the rest you'll see there's a 0, that one combination has a 0. So which 2 staff members can communicate directly with each other? So we'll just write their names. It was Bree and Dex. Okay, so today we're looking at dominance matrix, very similar to communication in terms that it's a square binary. So square binary means only 1s and 0s, and we have the same amount of rows and columns. Okay, but the thing with dominance, it's often used in games or tournaments where there is only 1 winner. So communication could go both ways. So you could have a 1 on both pairs if you have, say, between 2 people. But in dominance, we're always going to have a winner or a loser. And so that means there's, between 2 pairs, you'll always see a 1 and a 0. So we first set up the first matrix, and this would be what we often use the letter D, and that would indicate, and we call that 1-step dominance. So if we were setting this one up, it's very similar. You get your network diagram here. So if I look at if we go down here to, we would never, you don't compete against yourself. So A and A will be a 0. Then you looking at coming out of A. So the arrow's going that way. So it meant A defeated C, and that also defeated D. So on C and D, I'd put a 1. So over here, you have the winner. This is over that way is the loser. Okay. Oh, sorry. Winner might have 2 ends. Okay. And so then we put a 0 on the other ones because A lost against them. So then if we look at B, okay, so B, it beat A, it beat C, and it also beat E. So if I was filling that in, it beat A, didn't play itself, beat C, didn't beat D, and beat E. Okay, then if I look at the next one, if I go to C, C defeated D only, by the looks of it. So 0, 0, 0, D, 0. And then if we look at D looks like it defeated just B. Okay, so D defeated, it did defeat B. So I'll put a 1 there, 0, 0, 0. And E, the last one, who did E defeat? E defeated D, A, C, but not B. Okay. All right. So that's one-step dominance. Now, if you added up the rows, so if we added up the row across here, so that would equal, this one would be 2, this would be 3, this would be 1, this would be 1, and this would be 3. This is actually the number of wins, isn't it, for each person, okay? So we have this one-step dominance, and as they said, we looked at that. So if you're looking at this as a competition, we really don't have a winner as such because we have 2 people on 3 wins. So this is where we will look into looking at two-step dominance, and two-step dominance is found simply by squaring that first dominance, like in communications, okay? So let's have a look. This is two-step dominance. So they have squared this, the D matrix, okay? So what two-step dominance means, if you look at, say, if I looked at an example, I'll do an example here. So I'll do an example of this one, and I'll just explain what that 1 means. That 1 means that A beat someone who beat B. Okay? So what it means is A has a two-step dominance over B, meaning it can beat someone that beat B. So if you had a look, for example, can you see that who beat B? So C beat B. So yeah, anyway, so it has a 2, that's what it means. It beats someone who beat B, sorry. So this is just tells you the number of two-step dominance. So when they add up across here, it's the number, this is number of two-step dominance. So it doesn't mean you beat them, it means you beat someone that can beat them. All right, so D obviously, who else did B beat, got lost against? So B lost against D. So that's where A's got a two-step dominance over D, okay? So it can beat someone who can beat B. All right, so is we simply just square it and that's it, okay? So sometimes they ask us for the number of two-step dominance, so that's when you just find that. But often when we're finding the competition in a tournament, they will ask for the combination, and they'll say that the tournament winner will be the addition of D plus D squared, which means 1 and 2 step. Same as like with communication. All right, so if we have a look here, they say the tournament winner will add the 2 together. So when you add the 2 together, you then add up. So you do 2 matrix and you add this is the total, this is matrix T. If you, no, don't do that. Yeah, if you add these up, so you can see now we have a clear winner at B because B had more two-step dominance over, so we get a thing. So here's just the way to practice that. So when you're trying to work out a tournament, you would first work out the first dominance, then you'd get the D square of that matrix, add them together, and sum up the rows. So sum up the rows means you add them up, okay? Now, this would be an example of a SAC question. So here we've got an example. It said 4 people, A, B, C, and D, were asked to form a committee to decide on the location of a new toxic waste dump. So the previous experience is shown that A influences the decision of B and D. So what they're saying is that A is like the winner in the conversation. So we're going to call it like a tournament. So when we asked, so they've given all those things and then they say B influences the decision over C. But we've got been given a network diagram. Now this is also something that, you know, if you were doing a traditional SAC, they could just give you these dots, yes, and ask you to draw this up, okay? So you start thinking about things like that, and then they might ask you to create the dominance matrix, which is mainly what we need to do. So down here, I've written the dominance. We're calculating the first one, A, B, C, D. Okay, if your order of letters is going down A, B, C, D, that same order has to go across that way, okay? So if someone says you don't have to do A, B, C, D, it's just we're alphabetically orderly. If you had them around the other way, it doesn't matter as long as they both, the sides match. So you might get names that aren't so conveniently alphabetical order or something like that. So here we go. So if we have a look here, we can see that A beat B and D. So you can see there's the 1 and the 1 there. And we can see that B, they beat C only. So there's that 1 there. C beat no one. So we can see a whole lot of zeros there. And the last one, D, beat just B. Oh, and someone else, and C. Okay, so there's that. So then when I'm trying to find out it says here, it says use the graph to construct a dominance matrix that takes into account 1 and 2 step. So this is why this is in purple, because this is that answer. They've asked me to demonstrate the constructed dominance matrix, so they just want this final matrix. This is the answer to that question, okay? But I showed you how you would work it out. You'd find the D, put that in your calculator, you'd square it, and then that's what it would end up being. Then you add them together. So then we could tally it up, and A had 5, B equaled 1, C equaled 0, and D equaled 3. So we saw, even though in the beginning we saw that in the dominance, both A and D had the same amount of direct dominance. If you take into 1 and 2 stepped, A is the most dominant person there, having the most influence. Okay, so the network below shows the result of a chess competition with 5 players. So once you know you've got a competition with some type of sport or game, it definitely would indicate a dominance thing. So, and it says, obviously, the arrows indicate the winner of individual games, and they'll give you an example to explain that. So it says there, the sum of 1 step and 2 step dominance is calculated to give a player a dominance score. So we saw yesterday that we could set up the first dominance matrix. So I'm going to do that here in the blue. So what if you have a look, we know that I might just do the A one first. So we know A. So they didn't win, they didn't play themselves, so there's a 0. Now, if we look to see who A won against, and it only won against Donna. So there's why there's a 1 on the Donna. Okay, and then if I do another one, so if I look at Ben, so doing the next one, he beat Alex, so there's the 1. He also beat Elise, so there's a 1 on Elise. And he beat also Cindy, so you can see there's the 1 on Cindy. And then so zeros everywhere else. So this is the first dominance matrix. And this is pretty much the winners of the games, yeah? Winner of the games. So if you added all them up, you could see if you went along and you added up their totals. So this one was 1, this guy was 3, this was 1, this one was 2, and this one was 3. You can see you don't get a winner because there's 2 people that won 3 games. So we then look at doing, and they've asked us, so the way they're going to calculate dominance is they're going to do one and 2-step dominance. So here is where I've created this is the 2-step dominance matrix. And the way we've done that, we've created that matrix, is we've simply just squared that blue one. We've raised it to the power of 2, and we get this red. If you do it on your calculator, you'll get this dominance. So they've said the winner of that whole, to get outright dominance, they want you to add these 2 matrices together. So I've added them together, and down here is in the green is the answer to that. So I can tally up their 1 and 2-step dominance. So all I've done is added across the rows there, and we've gone that, and we can see that we get B with 8 points. So they're the most dominant. So they said to rank the players from highest to lowest dominant score. So B had the highest, so we wanted to see B first. Then Elise had the second, so she's in second, and so on, and that's how I found the answer. Okay, question 8. The matrix below shows the result of each match between 4 teams, A, B, and C, in a bowling tournament. Each team played each other team once, and there were no draws. So really what they've done, I don't know why I put C, but they've given you the first dominance matrix. So I'm just going to change these to D. It's a similar process, but we'll change that because we're going to use D. All right, so they've pretty much given you the dominance matrix, the first 1 step. So this is 1-step dominance. So that's what they've given me. And then it says down below, in this tournament, each team was given a ranking that was determined by calculating the sum of its 1 and 2-step dominance, okay? So once again, they want the sum of the 1 and 2. So that's what they did up here, okay? So the team with the highest ranked sum, was ranked number 1. So if you have a look here, I've done it. So I've squared that first matrix and got D squared and got the 2-stepped, and then I've added them together. So I got team C would be the winner, yeah, in this case to begin with. And then I had team B was second, and team A was third, and team D was fourth, okay. So it says using this method, team C was ranked number 1, and that's good, that's what I got. Team A would have been ranked number 1 if the winner of one match had lost instead of the match between they won instead of they lost, okay? So if one game changed, this would have mean that A won. So what I did is I've already entered it into my calculator, and this is question 8, so you're going to spend a bit of time. So I've put this dominance in, and I've had a look because they told me C1, so I've put it in and I can see that C1. But I did that and I put it in to have a look at who, because they said A would have won if one game was changed. So I wanted to look at where's ranking. So because B's come second, I'm thinking that the game is most likely going to be something to do with B and A, yeah? And A's got to win, obviously, to come back up. That's what you would assume. So what we're going to do is we're going to have a look at, you've got to look at the original. So we're going to look at this A game. And if you looked A actually, and you want A to win, and A actually already beat C. So that's not going to, we can't just give them a win there and change it. So that's not going to affect the ranking too much. We can't change it to win again. So, but if you look, see A lost to B. So we can see there. So what we're going to do is we're going to change that in our calculator, and we're going to change that to this one to a 1 and this one to a 0. Okay? And then we'll go pop that in our calculator again, and we would see, if we do it, we're going to see the new scenario of what's happening there. So I'm going to go do it on our calc. So I'll pause. Okay, so we've done that on the calculator. So we swapped this game, the A and B game, and then we've squared it again, the new one, and we got, this is our total down here now. So we've got this is D plus D squared. So if you look at our total now, we've got A on 5, B on 2, C on 4, and D on 3. So this, by swapping one game, it makes A the winner. So the game we swapped was A and B. Okay, 5 people, India, Jackson, Krishana, Leanne, and Mustafa, competed in a table tennis tournament. Each competitor played each other once only. Each match resulted in a winner or a loser, and the matrix below shows the tournament results. Okay, and then they're always going to explain what a dominance matrix is there. So a 1 means they won, and a 0. So they're all just giving you that example, and that will be thing. So then we're looking at the question part, starts here. So there is an error in the matrix. The winner of one of the matches has been incorrectly recorded as 0. This match was between. So what is happening is every pair, if you have a pair, say I and J, one of them has to have a 0 and one of them has to have a 1, okay? Because someone has to have won the game. So it might even be the other way round. So what they're saying is one of the, so you could have, or it could be 1, 0. But what they're saying is they've accidentally put it in as a 0. So it means between 2 pairs, we're going to see a 0 and a 0. So what you could do is you just go up and you check. So if we look at J and say J and I had a 1, okay? So then you look at J and I, there's also a 0. So it's not that one. They've both got a 1 and a 0, okay? Can anyone see it yet? So K, if I look at K and I, so K and I gave a 0. If I go K and there, no. Which one?
It's A.
So I and M. So we think it's I and M. So if we look at I and M, we've got a 0 there. If we go down to M and I, yeah, there's 2 zeros. So one of them should be a 1. So we're going with answer A. Okay, there are 5 teams, A, B, C, D, and E, in a volleyball competition. Each team played each other once in 2007. The results are summarised in the directed graph below, and an arrow from A to E signifies A defeated E. So there we go. In 2007, the team with the highest number of 2-step dominance. They just want 2-step dominance. So really all we need to do is find D squared and add up all those, the total of that. They don't want both. So that is the trap. Yes? They said just 2-step dominance. So first we've got to get the dominance matrix set up. So we'll practice that up here. And so we're going to have A, B, C, and D. A, B, C, and D. So if we look at A, who did A beat? Oh, sorry, is there another one? So we've got E as well. Sorry. So we've got A, B, C, D, E. D, E. Sorry. So who did A beat? A beat D and C. Is that it? Oh, yeah, and E. So A, B, C, D, E. Okay, who did B beat? E beat B and D. Okay, so zeros everywhere else. Who did C beat? Just B? Yep. D, they beat C and E. Yes? So C and E. And the last one, E, who did they beat? They beat C. And was that it? By the looks of it. Okay, so we need to go type this one in our calculator and square it. So let's do. Okay, so I've just squared that dominance matrix and I've get 0, 1, 2, 0, 1, 0, 0, 2, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, and 0, 1, 0, 0, 0. Is that recording? Okay, so we've squared the dominance matrix. Now they only want 2 steps, so I'm going to add up these rows, just the D squared. So this one is 4, this one is 3, this one is 2, this one is 2, and this one is 1. So the winner, the highest 2-step dominance is Team A. Okay, the graph below shows 1-step dominance between 4 farm dogs, Kip, Lab, Max and Nim. In this graph, the arrow from Lab to Kip indicates that Lab has a 1-step dominance over Kip. From this graph, it can be concluded Kip has a 2-step dominance over. So once again, we're going to have to set up the dominance because we've got to square it. So I'm going to go Kip, Lab, Nim and Max, and I have to do the same order along there. Okay, and I'm going to fill that in. So if I look at Kip, Kip can win against Max only. So Kip, Max, the rest 0. If I look at Lab, Lab beats only Kip and Nim. So Kip and Nim. Nim can beat Kip only. And Max can beat Lab, Nim, and that was it. Okay, so we've got to pop that one in and we're going to have to square it. So D squared will equal, so we'll do that on our calculator. Okay, so here I've found the dominance, I've squared it. If I tally it up, Kip has two-step dominance, so does 2, this is 1, and this one's 3. And it says, it can be concluded that Kip has a 2-step dominance over. So if I look at Kip, they only have a 2-step dominance over Nim. Okay, that's the only one he's higher than. So B, Nim only. Okay, question 4. 5 staff members in Elena's office played a round-robin video game tournament where each employer played each other once, and in each game there was a winner and a loser. Okay, it says at the table of their 1 and 2-step dominance was prepared in the summary. So we can't see the matrices. What they've done here, this is when if you had the 1-step dominance, you added up the rows. Yeah, and that's what they had. So really this is telling you their actual wins. Yeah, so if you wrote above that, that's the wins they actually had. Okay, and then the 2-step dominance was given, so they would have squared that dominance matrix. And this just tells you how many people they beat who also beat someone else, sort of scenario. Okay, so it says, considering the results, the matrix shown below, they're saying that 1 represents that the player defeated the other one. So in a nutshell, they are calling this the dominance matrix. Okay, So we have to go and use that information to find the original one. So if you have a look here, we've already got zeros all down the leading diagonal, so we could have worked that out because no one plays themselves, so that should always be 0. So we can see here too that we've got one, they've given us one game. They said K beat L, so K beat L there. So you should see when you've got L and K, you should see a 0. So L and K, but they've already done that, so we don't need to fill that in. That's already there, isn't it? Oh no, that's L and L. So L, K, 0, sorry. That would be here. We can put a 0 there, okay? Because we know those two, that. Now, what you've got to look at is we know up here from the winning thing that when we add up Ike, when we add across, we should get a total of 3 and a total of 3 here. Now a total of 1 there, which is good, that's what it is. And a total of 1 for Leslie and 2 for Mickey. Okay, so we don't want to go over that. So then what you've got to start having a look about, is the two-step. Like you can see the wins, but who won against who is still a little bit unsure. So what we're going to look at probably is to look at this two-step dominance. So Ike beat a lot of people, like has a lot of two-step dominance, which means that they're probably outright winning a lot of the games. And if you see Jolene is like second there. So we're probably going to go with, let's go with that Jolene so we know that. So they're probably going to be fairly dominant up here. So the other thing I looked at was when I did this is that you have Leslie only winning one game. Okay, so Leslie's got to win one along here. So we're going to have a guess that because Ike's got a lot of two-step dominance, probably not Ike and probably not Jolene. So we're probably left with only maybe, Mickey. So let's go with, if we put a 1 there. So we've gone with Leslie, we're going to say that there's a 1 against Mickey. So then go to Mickey and Leslie and make sure that that's a 0. So we're going to have to test it out anyway when we do it. So we'll go with that. Now, Leslie has a two-step dominance over someone else. So they've already beaten someone like that. So they've already got their one game, so we could put 0-0 everywhere else. So Mickey must have beaten someone else, to get the two-step dominance. And up here, you've got, when you looked at Ike being so dominant, I'm going to put that Ike loses against Mickey. Okay, because there's a two-step dominance, but it probably won't affect if he's beaten all those other ones. Okay, so if I put 1-1-1 across there, because I'm going to go with if he lost against Mickey, so I'm going to put Mickey wins against Ike, but loses everything else. Okay. So now you can see we've got the 3, so then we can go through and see what else. We know that Mickey got beaten by Jolene because we're going to go with the only beat Ike, okay? And we've got a 0 with Jolene and Ike because we said he won. We've got a, with Jolene and Kay, we're going to have a 1. Yeah, because K lost to everyone, and with L and J, so J we're going to put a 1 too. Now let's check our totals. Does that work? No. What did I stuff up? Oh, they're going to have 2. Okay. All right. Whoops. What have we done? Okay, so we've actually noticed that this one here, M and K, up here, is M and K is still 0. So we had to put that M beat K, yeah? And that one we could see. All right, so now we're going to fix that up. Now, do we have all the answers? Yes. So we're getting all this. So now what we're going to do is we got this tallies when we did that. So we're happy with that. So what we're going to do is we're going to pop this into the calculator and we're going to square it. And let's go and do D squared. And we'll see if we get that two-step dominance tally. So let's go pop it in our calculators. And I'm going to pause it. You guys chuck it in and see if you get it. Okay, so when we do this and we add up these rows, we get 5, 4, 1, 2, and 4, which matches the dominance, two-step dominance up here for that. So we've ended up with the right one.